Okay, so we have this question here. Get 1 second, let me get my pen up and running. There we go. It says test the claim that the proportion of people who own cats. So there's some keywords here. Proportion, we're talking about a proportion of people who own cats is significantly different. Not saying greater than, not saying less than, just saying different. So that implies not equal to. We're trying to show not equal to. 40% at the 0.01 significance level. So which one of these null and alternative hypotheses is the correct one? Well, if I'm talking about proportion, it's not going to involve mu. So we know it's not that. We know it's not that. And we know it's not that. So it's got to be one of these. Okay? Now it's trying to show that the proportion of people who own cats is just significantly different. Again, we said not less than, not greater than. So it's not going to try and prove it's less than that. It's not going to try and prove it's greater than that. It's going to try and prove that it's not equal to 0.4 or 40%. So there's the hypotheses we're going to go with, the null and the alternative. So if I'm just trying to show inequality, not less than or greater than, that's going to be a two-tailed test. Okay, so it says based on a sample of 600 people, 37% own cats. Well, that's all good and fine, but we need a number to put in our calculator. The calculator wants to know out of 600 people, how many own cats. So the first thing I'm going to do is figure out, well, what is 37% of 600? So we'll do 600 times 0.37. So 222 people. That's how many owned cats. Okay, so now I can go into the calculator, into my stat list, my test menu. And I'm talking about a proportion, so I'm going to do a one proportion z test. So then the null proportion is going to be 0.4. Out of my sample, 222 people own cats out of a sample of 600. And I'm trying to two-tailed test, so I'm going to calculate from there. And I'm left with a z value or a test statistic of negative 1.5. Two decimal places, that's fine. You can put a 0 there if you like. The p-value is 0.1336. Two decimal places will be 0.13. So my alpha is 0.01. So comparing the p-value to the alpha, p is greater than alpha. So there's a little tip you can use. I always say that if p is low, reject h up. So in this case, p is high. P is higher than alpha, so we fail to reject. If p was lower than alpha, we would reject h up. But since it's higher than alpha, we fail to reject the null hypothesis.